So let's move on to the last question of set HH, question number 180, that says that consider the following species, Cn plus, Cn minus, NO and Cn, and which one of these will have the highest bond order. The question is pretty straightforward once again. First of all, we need to write down the formula for bond order, which is half of number of electrons in bonding orbitals minus number of electrons in antibonding orbitals. All I have to do is write down the configuration for all of these four species and I'm done because I can simply calculate its bond order. So let's do that one by one. For Cn plus, my valence electrons are going to be 4 plus 5 minus 1 is equal to 8. So my configuration, outermost configuration is going to look like sigma 2s 2, sigma 2s star 2, sigma 2p 2, and pi 2p left are 2 electrons. So my bond order for this one is going to look like half of 2 to 4 minus 6 minus 2, which is 4 by 2 is equal to 2. Moving on to the second species, I have Cn minus. So for Cn minus, once again, valence electrons are 4 plus 5 plus 1, that is 5 plus 4, 9 and 1, 10. So my configuration here is going to look like sigma 2s2, sigma 2p2, sigma 2s2, sigma 2p2, 6. Then comes pi 2p, so 2, 6, and this is 4. This is sigma 2s star, that is my antibonding orbital, which implies my bond order is equal to half of 4 plus 2, 6 plus 2, 8 minus 2, that is 6, minus 2, that is 3. So that is for my Cn minus. Let's calculate now for NO. Third is my NO. So valence electrons is equal to 5 plus 6, which is equal to 11. So my configuration is going to look like sigma 2s2, sigma 2s star 2, sigma 2p2, pi 2p4, 4 plus 6, 2, 8, 10, and the one left is pi star 2p1. So my bond order over here is going to look like half into 2 plus 2, 4 plus 4, 8, minus 2 plus 1, that is 3. So this is 2.5. Finally, I have Cn. So this is 4 plus 5, that is equal to 9. So I'm going to have sigma 2s2, sigma star 2s2, sigma 2p2, 6, and pi 2p3, right? 2 plus 2, 4, plus 2, 6, plus 3, 9. So because, so these are my valence electrons basically. So my bond order now is going to look like half of 3 plus 2, 5, 5 plus 2, 7, 7 minus 2, that is 5 by 2, that is 2.5. So as you can see, the highest bond order is for my Cn minus, and this Cn minus, that is my 3, and thus, so the correct option for Cn minus is my option number 4 for set HH. So this was about it. I simply calculated the valence electrons for all the 4 species, and then I wrote down the electronic configuration, and my bond order is basically half of number of electrons in bonding orbitals minus number of electrons in antibonding orbitals. And that's how I calculated bond order for all, and I concluded that for my bond order for Cn minus was highest, that is 3, which corresponds to option 4. So this was about question number 180.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.